Hello everyone, my name is Gulbarshin Mukasheva. I am a PhD senior teacher of the Department Epidemiology and Biostatistics. I would like to present to you a lecture called Measures of Central Tendency and Dispersion. Descriptive statistics helps us summarize and describe data in a simple and clear way. We can divide descriptive statistics into two parts: averages, measures of central tendency. This includes the mode, median, and mean. They tell us the center of the data. Measures of dispersion. This includes the range, interquartile range, sum of squares, variance, and standard deviation. They tell us how far the data values are spread out. Finally, we also have bivariate descriptive statistics, such as contingency tables and correlation analysis, which describe the relationship between two groups. Now let's talk about the three main measures of central tendency: mode, median, and mean. Mode is the value that appears most frequently in a dataset. Sometimes the dataset can have two or more modes. If there are two modes, we call it bimodal. If there are more than two, it's multimodal. This tells us that the data are not uniform. Median is the value that divides the ordered dataset into two equal parts. Half of the values are smaller and half are larger than the median. To find it, we arrange the numbers in order. If the number of observations n is even, the median is between the 0.5n and 0.5n plus 1 values. If n is odd, the median is the 0.5n plus 1 value. Mean is the arithmetic average of all values in the dataset. Let's now look at how to measure the spread of data. Range is the difference between largest and the smallest values. Interquartile range is the difference between the third quartile and the first quartile. It covers the middle 50% of the data. Sum of squares is the sum of all squared differences between each value and the mean. Variance is the average of these squared differences. The larger the variance, the greater the spread of the data. Standard deviation shows how much an average each value divides from the mean. It is the square root of the variance and is one of the most common measures of dispersion. There are several types of averages. The most common is the arithmetic mean. It's used when the data increase or decrease in equal steps or arithmetic progression. The formula is m equal to, here shown in this slide, formula. And for example, 15 plus 20 plus 15 plus 16 plus 15 plus 18 plus 16 plus 23 plus 15 plus 20, and we will divide it 10 equal to 171 divided 10 equal to 17.1. So the mean equals 17.1. Mode is the value that occurs most often. Median is the value that divides the dataset into two equal halves. The position of the median can be found using the formula n plus 1 divided 2. Mean square deviation. The mean square deviation, also called the standard deviation, shows how far the values are from the mean. Here the steps to calculate it: find the arithmetic mean, find each deviation, from the mean, square these deviations and sum them, find the average of the squared deviations. This is the variance. Take the square root of the variance, that is the standard deviation. This value tells us the average amount of variation in our dataset. Standard error of the mean. The standard error of the mean or standard error measures how much sample means vary from the true population mean. It helps us understand how accurate our sample mean is as an estimate of the real mean. We can calculate the error for absolute arithmetic mean and relative indicators. In other words, standard error gives us an idea of how reliable our sample mean is. Here shown formulas. Next, variance. The mean of the sum of squared deviations from the mean or the average of the squared differences from the mean. For example, if we have the following observations 3, 5, 7, 9, 11, then the mean is 7. Now let's calculate the deviations for each value from the mean. Here shown calculations. 3 minus 7 equal to minus 4, like this we'll calculate. If we simply add the deviations, the result will be 0. However, if we square these deviations and then sum them, the result will no longer be 0. It will be as follows. Here shown all calculations, and at the end we will find variance equal to 40. It's calculated using the following formula. Here you can see two formula. One is for sample variance, second is population variance. Properties of variance. Variance is never negative. All observation values are taken into account. A drawback of variance is that its unit of measurement is in squared form. Based on the example above, to calculate the sample variance, we divide the sum by n minus 1. 5 minus 1 equal to 4, thus 40 divided 4 equal to 10. Then we will find a variance as a 10. Standard deviation. Standard deviation is a measure that indicates how much the observations in a sample or population divide from the mean of that sample or population. It is the square root of the variance and therefore has the same unit of measurement as the original data. Standard deviation is one of the most commonly used measures of dispersion. Based on the previous example, to calculate the standard deviation, we take the square root of the variance. Thus, the mean can be expressed as 7 plus minus 3.16, because our standard deviation was 3.16. In articles, we will write like this. Standard error of the mean. When we take a sample from a population and calculate its mean, it may not exactly match the true mean of the population. If we take another sample from the same population and calculate its mean, it may differ from the mean of the first sample. Similarly, this mean may also differ from the true population mean. This phenomenon is called sampling variation. Standard error of the mean. This measure quantifies the deviation or variability of a sample mean from the population mean. It's used to estimate the population mean and to access differences between the mean of population. Here you can see formula. Based on the previous example, standard error, here shown all calculations. At the end we will find standard error equal to 1.4. Coefficient of variation. The coefficient of variation expresses the standard deviation as a percentage of the mean. Here formula shown, where m is the sample mean. It's unitless, used to compare the dispersion of two data sets measured in different units. Measures relative, not absolute, variability, takes all values in the dataset into account. For the previous example, coefficient of variation equal to 45%. Thank you for your attention.